let's look at these three properties. If they both have the same base but different exponents, your answer is simply going to be the sum. You keep the same bottom, base, and you add the exponents. It's pretty cool. What you'll see for this property is whenever you take a power to another power, you multiply the exponents. So here you added, here you multiply. And for this one, you take two things, like two terms that are multiplied, and they both go to the nth. So your answer would be, this whole thing to the nth would be a to the nth times b to the nth. It's kind of like the n distributes to both pieces. So those are your three properties. You need to know those to do the next couple problems. Number 1, 7 squared times 7 to the 4th. What you should notice when you look at these problems, it's this one. They both have the same base, and so according to what this says, you just add the exponents. So my answer is just simply going to be 7, and then you add these, so it looks like 7 to the 6th. And we'll leave it like that. I'm not going to worry about multiplying 7 6 times. Now, here's why it works. It's kind of cool. 7 squared is 7 times 7. That's your first piece. 7 to the 4th is 7 times 7 times 7 times 7. Do you see 6 sevens? Isn't that 7 to the 6th? That's where it comes from. And it's sometimes good just to know where things come from. All right, for this one, it's still first property. And what you notice is same basis. So what we're going to do is we're going to add the exponents. So we simply have x to the 3 plus negative 4. Now 3 plus negative 4, well, 3 plus negative 4 is negative 1. So it looks like we now have x to the negative first. And according to previous properties, any negative power, that becomes 1 over x to the first. And you don't need a first power, so you can always just, anytime you have to anything to the first, you can simply drop the power. So 1 over x. All right, number 3 here. This looks like this one right here. You take something to a power to another power. So according to the rule, it's simply going to be c to the 4 times 2, which is c to the 8th. That's your answer. That's the shortcut. Where does that come from? Well, c to the 4th squared means c to the 4th times c to the 4th. Okay, actually let's write it this way. C to the 4th squared means c to the 4th, c to the 4th. And then go back to this property. Don't we add 4 plus 4? Isn't 4 plus 4 8? That's the long way. Or you could write this as c times c times c, 4 of them, and this is 4 more c's, and you'll see you have 8 c's. All right, so let's take this same property we just did and deal with this problem. So first thing here is to take a power to a power, so that means we multiply those. So this looks like it's going to be d to the negative 3 times 4. And this one's going to be d to the 2 times 3. Remember, power to a power, you multiply. So that looks like we got now d to the negative 12th times d to the 6th. Okay, and then we look here. Oh, that looks like this property right here, or this 1 and 2, which means you can add these powers. So it looks like my final answer would be d to the negative 12 plus 6. And you add the powers, so finally we have d to the negative 6, because negative 12 plus 6 is negative 6. Oh boy, this one's long. D to the negative 6. Isn't that 1 over d to the 6th? That one took a while. So you first take them to the powers, then once you take them to the powers, then you add the powers, and then any negative powers you drop. Okay, number 5. Number 5 looks a lot like this one. See right here? A, B, this is A, this is B, both to the n. So what this one will look like is this is going to be 5 squared times x to the 3rd squared. Do you see how I distributed the squared basically to both pieces? So what we have here is 5 squared. Well, that's going to be 25. And x to the 3rd squared, you multiply 3 times 2, so that's x to the 6th. There's the answer. Now, here's technically where it comes from. technically 5x to the third squared is 5x to the third squared means times itself. And so that's 5 times 5, which is 25. X to the third times x to the third is x to the 6th. So that's, you kind of write it the long way. It can help you sometimes. Last two. Number 6. Let's take all these properties and put it together. First thing for this one, you're going to distribute that. So you're going to have a, and that's 6, a to the 6th to the third, times c squared to the third. And this is still going to be ac to the negative 5th. Stays there. And it looks like that will become, sorry, a to the 18th times c to the 6th, because you multiply those, and then times a times c to the negative 5th. And then for this one, what you'll notice is you're going to take, I kind of separated this, just take the a's, make that a 1 power, because there's nothing there. So you're going to add it. A to the 18th plus a to the 1st is going to be a to the 19th. And then these are going to combine, and 6 and negative 5 will give you c to the 1st, which you don't need to put the first power. So there's your answer. Again, once you get to here, you combine the a's, combine the c's, and then you add the powers of each. Last problem. You have these two problems. Basically, your first thing you do is multiply these two front numbers. So negative 8 and 5 gives you negative 40. Then you're going to multiply these. When you multiply those, you add the powers. So you're going to have simply c to the 2 plus negative 7. You're going to add the powers. This is actually a really simple problem, because once we got that, it's negative 40. And then, so it's negative 40, it doesn't change. And then 2 plus negative 7 is negative 5. So that's c to the negative 5th. And remember, we don't want negative powers, so we drop it to the bottom. So the negative 40 stays on top. Some people think that negative 5 goes to the negative 40. It doesn't. Just that negative 5 goes to the c. So it's c to the 5th. Negative 40 over c to the 5th is the answer.